Okay, chapter 1, section 6, problem 3. The position of a particle moving along there is given by this equation. Use the different quotients to find the velocity t and acceleration t for the following expressions. So, to find the velocity, I have to do, and then dividing by h, so we're doing that one. So we're going to do f of a plus h minus f of a over h. And so I got to put a plus h in here, but it's t, and we want to use t for the a and h otherwise. So we're going to have 8t plus h squared plus 5. That's the function with t plus h in for the t's. There's only t in one spot there. Minus just f of t. So that's just this function, 8t squared plus 5 divided by h. So t plus h squared is going to be t squared plus 2th plus h squared when I multiply t plus h times t plus h. And then I got to take that times 8, so I'm going to have 8, 16, and 8. And then I'm going to have minus 8t squared plus, actually minus, because I got to go minus to both of them, minus 5. And this is all divided by the h. And the 8t squared and the negative 8t squared cancel. And, ooh, I forgot the 5. Plus 5. And the 5 and the minus 5 cancel. That has to cancel. So I have, kind of hard to read it here, 16th divided by h, which would be 16t. And then I'm going to have 8h squared divided by h, which is going to, I'll write it here, 16t h minus 8h squared divided by h. H is going to go into here and cancel that. H is going to go in there and cancel one of those. And then I'm supposed to be finding the limit as h goes to 0. So there's no h in this, so I get 16t. There's h left here. When that goes to 0, that's gone. And so there's my answer. Now I'm supposed to find the acceleration, which means do the process again, but on the velocity graph to get the acceleration. So I'm going to write 16, putting t plus h in place of the t, minus, and then I'm going to put just the t in there, divided by h. So I get 16t plus 16h minus 16t over h. These two cancel, and I've got to find the limit as h goes to 0, but I can't put it in because I'd have division by 0, but these cancel, and I get just 16. All right, number 4. The P of T is the present price of the stock at a time. So the price depending on the time. The price of stock is falling slower and slower. The first derivative of P of T is, okay, so the price, whatever it is falling, but it's falling less quickly. So the price of the falling, the first derivative, so that's the slope. The slope is, therefore, getting less negative, getting more positive, so it's increasing. I think that's what one of the choices is. The second derivative, we'll be looking at how this is changing, or the curvature of this. This is curved up, so the second derivative is positive. And maybe this one was positive or negative. The first derivative is negative because it is still falling. But the second derivative, it's getting less. The derivative of the derivative is increasing, positive. So it's increasing. I'll have to look at here. Let me look at the book and see what are the choices. Pulling that up. You won't see this, but I will. Nope, not there. Is it there? Nope. No. Yes. Okay, so this is in 1-6, problem 4. Problem 4. So for here, we had to decide whether it was positive, 0, or negative. So the slope is negative, and the second derivative is positive because this is increasing. Even though it's a negative slope, it's increasing. The rate of increase of the slope of this curve is positive. The price of the stock is close to bottoming out. The first derivative, P of t, is the derivative. If it's close to bottoming out, the slope is close to 0, which is one of the possibilities. And the second derivative is still increasing in slope, so it's still positive because it's curving up. It's a positive second derivative means concaved up. The slope is increasing. Okay. And then we have problem number 7. Suppose the accelerating car goes from 0 to 58.6 miles per hour in 5 seconds. Okay. Its velocity is given in the following table and converted from miles per hour to feet per second. So it goes from 0 to 86 feet per second, which is about 58.6 miles per hour. Its velocity is given in the table. This is the velocity, how fast it's going. And all the times are in seconds now and this was in seconds originally. Note 1 mile an hour is this, and so that's how they converted. Find the average acceleration of the car over each of the first 2 seconds. So over the first second, the average speed would be, the average acceleration would be the change in the velocity. So it goes from 0 to 29.3 or 29.32 over change in time of 1. So it's 29.32 feet per second faster every second. You could also type that in as feet per second squared. The average acceleration over the second, it went from 29.32 to 50.82, so I'd have to find the difference there. That's 50.82 minus 29.32. This is 0.50, and 9 from 0 is 1, and 2 from 4 is 2. So it's 21.50 feet per second faster every second. And that's the acceleration. How much does the speed change per second? Okay.